All right, so 5.2 then. These are triangle congruence by side, 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 and side angle side. That's what the SSS and SAS stand for. Side, 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 side angle side. Okay? What we're going to do throughout this unit, and each section we'll talk about a couple different shortcuts. Some of these shortcuts are going to work, and some of them will not work. Okay? Our goal is to figure out, to be able to make a list and say which shortcuts work and which shortcuts don't work. Because it takes a lot of time to say all three sides are congruent and all three angles are congruent. But if these shortcuts would work and we could say, oh, all three sides are congruent, cool, the triangles are congruent. If it works, then we'll be able to do that and we don't have to find all 6 parts. We can stick with finding 3 good parts. Does that kind of make sense? So they're shortcuts. We like shortcuts, right? We like to make our lives a little bit easier. So our goal today is to identify and use side, 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 and side angle side postulates. So the first one is the side, side, side shortcut. It says, if 3 sides of one triangle are congruent to 3 sides of another triangle, are the 2 triangles congruent? The way that we're going to find this out is everybody has the same 3 segments. We're all going to construct a triangle, and we're going to see how many different triangles are formed throughout the classroom. So everyone, right now, you are going to construct these 3 segments into a triangle. So remember, in order to start this, you need to start with array. Pick one of the segments. You get to choose which one. And copy that segment. So open up your compass, measure it, mark that little arc, copy it by putting the point of your compass down here, copy that arc, or here, or this one, just depending on which one you want to use. And you're going to copy one of those segments onto that ray. That's your first step. And then mark which one you copied. So if you copied this one, mark it. Put one arc or one dash and a dash so you can see which one's congruent. So if I were to do the middle one, I would do the point. I'd make an arc, copy that arc, and I just marked this congruent to this. And I already have 2 points of my 3-pointed triangle. Okay, you might have started with a different one. That's totally fine. Now pick your next arc that you're going to have to measure. So this side, maybe you want it coming off the left side. If that's the case, measure a second segment. It doesn't matter which one you go to next. And make an arc coming off that side. So I know whatever side it goes here, whether it's to here, to here, to here, it's going to match this side that I did. Then I'm going to take my last side coming off of the next point, make that arc, and where those 2 arcs meet is the 3rd point of your triangle. This one matched with that one. Now everybody constructed one triangle. I think that's the only, they might be moved around a little bit, but I don't see another way I could have constructed that other than if I started differently. So look at your neighbors. Look at the person behind you or the person in front of you. Look at your triangle compared to theirs. Could you lay them on top of each other? Would they be the same triangle? Would they be the same size, the same shape? What do you guys think? What are you noticing? Are they all the same? Some of them are what though? Some of them are rotated, some of them are turned, right? But didn't we learn rotations are what? What's that word? An isometry. What's an isometry? What's an isometry? Isometries are things like translations, rotations, reflections, but what happens to them? They're still the same size and still the same shape, right? They just move. So even if your neighbor constructed theirs a little bit differently, they still have the same triangle there. It may have just moved a little bit. Do you notice that? So if you have three sides of a triangle, and I can even show you with these, okay? I could take three of these pieces and say, okay, here's three sides of a triangle. So far, so good? I'm going to put them together. It does not matter the order I put them together in, but what's going to happen is I could take this apart, and no matter how many times I put it together, it's still going to create the exact same triangle. It might be like this, it might be like this, it might be like this, but I can keep taking it apart, and the green has to be touching the blue and the red has to be touching the green and the blue has to be touching the green and the red. It's going to be the same triangle no matter how I put this together. Because even if I take it apart and put it together a different way, still makes up the same triangle. Okay, so if you have three sides of one triangle congruent to three sides of another triangle, then the two triangles must be congruent. That's what that theorem or postulate says. The side-side-side postulate says that if three sides of one triangle are congruent to three sides of another triangle. So in this example, we have two triangles here. We have this side marked, and the third side marked, all marked congruent to each other, right? So if three sides of one triangle are congruent to three sides of another triangle, what we have in this picture, then the first one, triangle ABC, the triangles must be congruent. So triangle ABC is congruent to, you have to be careful, A goes to B, it goes through the one dash, then through the triple dash. Through the one dash, through the triple dash, D, E, F is how I have to name that second triangle. So again, you have to be careful on how you name the triangle, okay? Because A has to be in between the one and the double. In between the one and the double is D. So A and D have to match. In between the single and the triple is in between the single and the triple. B and E have to match. Do you see how you can match them up here? So that means that we no longer have to show all three sides and all three angles are congruent. If we have all three sides, we can stop there and say, because of side, 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 the triangles are congruent. Your proof that we just learned just got way shorter. It got half the length. Right? Do you see the difference? So we're going to come up with more of these shortcuts that also work. The next one, investigation 2, is working with side angle side. Okay, now for side angle side, we're going to again start with a ray because we have to copy the angle first. So start with that ray. from that ray, what we are going to do is we're going to copy this angle onto that ray. So you're going to put your point on the point of the angle. Remember, you want to open up your arc as big as you can while still staying on your paper. Copy that arc down there. Next, we're going to have to measure this arc to copy that measurement down here. So I'm going to put my point on one side of the arc, open my compass or close my compass, depending on where you were at, to figure out how long is that arc. And then I can copy it onto the arc to say the ray of my angle has to go through that intersection, and there's my angle. All right, so there's that angle. Then what we're going to do next is you can take, and it doesn't matter which side you choose. If you want the long side on the bottom or the short side on the bottom, you choose. But measure one of these two and copy that measurement on your one ray. Then take the other one and copy that measurement on the second ray. So you can do that now. Maybe I want the longer one as the bottom, or maybe I'll do the shorter one as the bottom. And maybe I'll do the longer one as that one up top. And now what I have is I can connect those 2 points I found, and that's the third side of my triangle. Compare your triangle with the people around you. So I'll highlight mine so you can see it better. So that was that side. This was this side. And this angle was the angle between them. And that's the triangle I found. Okay, so what do you guys notice between yours and your neighbor's?